When you have Microsoft Fabric in your organization, you can access all the data regardless of where it is using OneLake, which is built into the platform. This session will specifically focus on that aspect of Microsoft Fabric. Whatever your role is, Microsoft Fabric offers a different experience to each type of user. What we discuss here today is in the Synapse data science experience. In a typical enterprise scenario, data is scattered across different sources, both internal and external to the organization. In addition, ETL or data pipeline processes copy the data to different available databases to backup, join, or enrich the data. The objective is to store the data in a central location called the Enterprise Data Warehouse, or EDW, and from where it can be used to generate reports for management. With Azure Synapse Analytics, the same scenario can be modeled using a host of Synapse Analytics instances to copy, enrich, and store the data. Where needed, Microsoft Power BI can be used to report on the data as well. The thing you might have noticed is that multiple copies of data are stored in SQL database pools, either serverless or dedicated. One aspect of this implementation is the presence of multiple instances of Azure Synapse Analytics that are maintained by different teams within the same organization. With Microsoft Fabric and OneLake, the implementation changes drastically. You still have all the data sources that the organization needs to access, but the data in those data sources surfaces through OneLake. I just want to point out that the OneLake connection to the Google Cloud Storage is still under development. Because the data is exposed in one location, Power BI can access that data source to generate reports. So what exactly is OneLake? We use the term lakehouse when we are talking about data architectures. The term lake can be confusing because it is used in a lot of different contexts. You will likely hear the terms lakehouse and direct lake when someone talks about Microsoft Fabric. While these two terms are connected to OneLake, the term direct lake is a brand name given by Microsoft just like OneLake, whereas the term lakehouse is general terminology. Direct lake is related to Microsoft Power BI and not covered in this session. Lakehouse is a general term and related to the lakehouse architecture. Microsoft also uses the term lakehouse in Microsoft Fabric. Like before, the term lakehouse architecture is a general term used interchangeably with lakehouse, whereas lakehouse is also a brand name used by Microsoft in Microsoft Fabric. We will cover these terms in this session. Lakehouse architecture simply means that there is a central storage called lakehouse that stores files and tables. This data is then used to generate reports. On the other hand, OneLake consists of multiple lakehouses created by users. Each lakehouse comprises of data that contains both files and tables. In a general lakehouse architecture, the lakehouse is able to read and write data. With Microsoft Fabric, OneLake and its contained lakehouses are read-only. This means that only select is allowed, whereas insert, update, and delete are not. You can, however, add data from external data sources to each lakehouse. The idea behind this is that each lakehouse exposes its data to OneLake, and reports in Power BI can use data from both OneLake and lakehouses. This eliminates the possibility of multiple copies of the same data scattered across the organization. This is in sharp contrast to the lakehouse architecture, where many instances of the lakehouse are spread across departments, organization units, or Azure subscriptions to allow the users to connect using SQL Server Management Studio, Blob Explorer, etc. With Microsoft Fabric, OneLake is tied to the organization tenant, which means only one exists at a time, and you can view the contents of the OneLake using OneLake Explorer. Lakehouses are created by users, so multiple instances exist. You can view or add contents to the lakehouse using the Lakehouse Explorer. The OneLake Explorer must be installed and adds capability to look at the data using Windows Explorer that you have on your desktop machine, whereas the Lakehouse Explorer is web browser based. Let's focus our attention to OneLake, which is used to view data from 3 lakehouses in this scenario. I mentioned before that each lakehouse is used to store tables and files. You can also create shortcuts to ADLS storage or an S3 bucket. Shortcuts simply copy the data from the sources to the lakehouse. Whenever a lakehouse gets created, a SQL endpoint is automatically created for it, which enables programmatic access to that lakehouse. Each SQL endpoint is in the form of a Uniform Resource Identifier or URL, uniquely identifies the lakehouse and provides read-only access to it. So far so good, but how do you populate OneLake? OneLake and each of the lakehouses are read-only. What that actually means is data can be read from them but cannot be written to the data source they represent. You can, however, add data to them. Let's look at a hypothetical scenario from the earlier example. Each lakehouse represents a city and feeds data to the one lake maintained by the central government. We will look at the lakehouse that is maintained by the city Islamabad. You can view the contents of the lakehouse represented by the icon at the bottom left corner. For this example, we will look at a separate window, the Windows Explorer. To view OneLake, you will have to install OneLake Explorer on your computer. You will then see the OneLake node in your Windows Explorer window. Click on the OneLake icon to view the workspaces contained within it. Let's look at Workspace 3 by clicking on it. You will see the Lakehouse from Microsoft Fabric on the server in your Windows Explorer window. If you click on the Lakehouse, you will see the Files and Tables folders. Click on the Files folder and upload the sales tax flat file. Now go back to your web browser and view the contents of the Files folder by clicking on it. You will see the sales tax file you added using Windows Explorer. Rename the file. And if you go back to the Windows Explorer on your client machine, right-click and select Sync from OneLake in the context menu. You will see the renamed file in your Windows Explorer. To summarize, in a typical scenario, an organization has multiple islands of data that it needs to access. The organization needs to move, copy, or transform that data between different organizational units that maintain it. Also, each organizational unit needs to maintain some code and reports that they use with the data. All that has to roll up to the main organization that has to sift through multiple copies of the data with slight differences to generate reports. With Microsoft Fabric, the data islands are replaced by lakehouses that show data from Azure Data Lake storage accounts or S3 buckets in Amazon. The lakehouses have Power BI reports and Jupyter notebooks that access them. The data rolls up to the OneLake maintained by the organization, which is the one version of the truth to generate reports. Thank you for listening.